All right, as we look at starting a new unit here, we are going to talk about the counting principle and permutations. Principle, not principles. So the counting principle kind of works like this, and it's kind of easiest to show using something we call a tree diagram. So let's say that the sporting goods store has 3 different types of snowboards, all mountain, freestyle, and carving, and then 2 types of boots, soft and hybrid. How many choices does the store offer? So first off, you do is you list all 3 of your types of snowboards, and then each one of those snowboards gets a boot, a possible boot. I just labeled them A, B, A, B, A, B, A, B. So if you combine those, again, draw a tree diagram. This would be like 1A, this would be 1B, 2A, 2B, 3A, 3B. They have a total of 6 possible choices that you could do. So using a tree diagram, maybe there's a faster way. There is, and this is what kind of like our big idea is the fundamental counting principle tells us that if we have X amount of choices and we have Y amount of choices, we can multiply those 2 ideas together, X times Y, and get the total number of possible choices. So again, notice that if you have 3 or more, then you have to multiply it by more things. M times N times P times O if you had 4 different options or choices. So let's take a look at an example and say you're framing a picture. The frames are available in 12 different styles, and each style is available in 55 different colors. Let's get see if we can get fancy here. I think there's one that I thought you could change the color to like all the colors. Well, anyways. I don't know what I just did there. Well, that's cool. All right. Get rid of this. Colors. So we can use, and then in addition, we also want blue mat boards, and there are 11 different blue mat boards. So to recap, we're going to do a picture frame with 12 different styles, 55 different colors, and 11 different blue kind of, I'm assuming that means like the backdrop of the picture frame. How many different ways can we frame the picture? How many different ways can we frame? Oops. So imagine trying to do a tree diagram with 12 different styles. And each one of those had 55 different colors. And each one of those had 11 different shades of blue. It'd be exhausting. So we'll use the fundamental counting principle to say I have 12 choices times 55 different colors times 11 different blue mats, which is going to give me a total of 7,260 different ways. So we saved ourselves a whole heck of a lot of time by not having to graph that. Sometimes you can use the counting principle, but letters can repeat. So let's think about like a license plate. So a normal license plate, say you've got the state up here, you often have, a couple letters and a couple numbers. So in this case, it's actually the example we have is the state of Texas, and they have one letter followed by 2 digits followed by 3 letters. So A99 and then something like AAA. So let's see here. 1 letter, 2 numbers, 3 letters. 2-part question. How many different license plates are possible if letters and digits can be repeated? So repeat if the letters can repeat and the digits. And then the second part of the question is to not repeat. So if we think about that, the first thing I'm going to think about is 1 letter. I know that there are 26 letters. And then the second thing I'm going to choose, so again, eventually I have 5 choices to make. So then I'm going to say, all right, I know that there are a total of between 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 choices I can choose for a letter or a number. And because I can repeat, I'm going to choose 10 again. And I'm going to keep doing that because repetition is okay for part A. So I still have 26 choices that I can choose from. So when we go ahead and multiply 26 times 10 times 10 times 26 times 26 times 26, please use a calculator. We get 45,697,600. Again, that would be the number of plates or the number of license plates combinations. But if we can't repeat it, now our first choice of letter still has 26. Our first choice of number still has 10. However, if I can't choose, if my number was a 3, I can't choose 3 again. So that means I have 0, 1, 2, 4, 5, 6, 7, 8, 9. I only have 9 choices left. Same with my second letter, number spot 4 here, okay? I've already picked 1 letter, which means I don't have 26 letter choices anymore. If I can't repeat, I only have 25. And then I only have 24. And then I only have 23 choices to finish it off. So when I multiply all that together, I get 32,292,000. So it is a significant difference between the two, determining whether we use repetition or we do not use repetition. So if the order matters, we call it a permutation. So oftentimes you might think your locker combination works, but if you type in your locker combo in the wrong order, it's not going to work. The permutation order, so it's actually a locker permutation. So if we try to permeate A, B, and C, we get 6 choices. A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, and C, B, A. And again, that makes sense because our counting principle, 3 times 2 times 1 gives me 6. This expression, 3 times 2 times 1, is actually, or can be written as a factorial. So 3 with a with an exclamation point next to it is a factorial. And so again, doesn't matter what the number is, you will just multiply down. So whatever that number is, you're going to multiply it all the way down until you get multiplied by 1. All right, a couple more examples. 2 more examples here. 10 teams are competing in the final round of the Olympic 4-person bobsledding competition. So part A is how many different ways can the bobsledding teams finish? Assume no ties. Um, 10 teams again. And then part B is how many different ways can 3 of the bobsledding teams finish first, second, and third to win the gold, silver, and bronze. So different ways just the 3 teams can finish. So again, if we think about the very first example, part A, if there are 10 total teams, I can use 10 factorial, or 10 times 9 times 8 times 7 to figure out the possible order of how many different teams can finish the competition. What are the different ways that they could? And it's possible. Is it likely? Maybe not, because some teams might be better than the others, but it's possible that you could have that many. Whereas if I'm just looking at 3 specific teams, so whatever team finishes first, I then want the other team to finish second, and then I want a different team to finish third, gives me only 720 choices. So it's good to get this in your notes here. This is kind of our generic concept for a permutation, and it's written with NPR. So again, N is kind of like the total number, and then R is how many specific things that you want. So we could use this previous example. So if we use this previous example, we would say, all right, 10P3, which again is equal to 1098, which if you think about what happens on the top, I have 10 times 9 times 8, 7, 6, 5, 4, 3, 2, 1, and then it's all over 7 times 6 times 5, 4, 3, 2, 1. There's a lot that's going to be canceling out. Cancel, 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 cancel. So what did we really do? We really had 10 factorial divided by 7 factorial, which you can figure out from the equation is 10 minus 3 factorial. So if you get something that looks like this, you know how to solve it by using this equation. N is your number of teams, and then you wanted just the first 3 teams. You wanted the first, second, and third places. If we look at permutations with repetition, so let's say that we have the number of distinguishable permutation of the letters Miami. So again, you may have some letters that repeat, and Tallahassee. So Miami has 5 letters, and it has an M that repeats, and it has an I that repeats. So I'm going to say that we have 5 letters that has 2 repeats, so we are going to use the base formula of n factorial all over s sub 1 factorial. So however many things you have repeating all the way to s sub k factorial. So if we try to use this, we'll say, all right, we have 5 letters and we have 2 letters that repeat. So we're going to end up with 120 on the top, and 2 times 2 is just 4. So this gives me 30 possible letters, or 30 possible ways that I can reorganize those letters, counting those letters that are doubles. And let's see here. We've got 3 A's, 2 L's, and 2 S's, it looks like. And I didn't even spell Tallahassee right. There's actually another E on the bottom. Wow. So we have 2 more of those. So I have a total of 11 letters. So again, I'm going to use my kind of formula. I'm going to say, all right, I have a total of 11 letters. And I know that A repeats 3 times. L repeats twice. S repeats twice. And E repeats twice. So this gives me 39,916,800 on the top. 6 times 2 times 2 times 2, 12. 6 times 2 is 12, times 2 is 24, times 2 is 48. And then when I divide those out, I get an answer of 831,600. So assuming that order matters, I can reorganize those letters 831,600 times.